welcome. Thank you very much for coming for this to this tutorial that is sort of a mix of a workshop, because we have a lab, a guide, a step-by-step to go over everything that we're going to talk in this tutorial. Can you go? Okay, perfect. And then the idea is we're going to introduce the Kubernetes machinery. At least the most interesting part is the Kubernetes resource management, the resource model, that is going to help you to understand what are the what could be the full advantage that you can get from Kubernetes in order to use it for your network automation use cases. Kubernetes is very popular, has a container orchestration solution, but today we are going to show a different approach. And also we are going to introduce a new project, open source project. I know you are pretty familiar with Containerlab and GNMIC. Now we are going to introduce also a project called Kubernetes, where we have a couple of applications that maybe could be very interesting for you. Alejandro is going to take the first part of this tutorial. He's going to show you the evolution of taking an application like a traffic generator based on iPerf3. He's going to put it in Kubernetes. The good thing is Containerlab today supports kind. And then you can just go and start your lab with Containerlab using Kubernetes like endpoints for your lab. And then he's going to show you the way that you can upload iPerf as a cloud native solution inside those Kubernetes, and show you the way that you can manipulate that application, create multiple streams. Personally, for me, it was important because I always try to test ECMP groups, layer 4, and it was a little of a problem when we were just using the ping. Then I needed something that can help me to understand how to spread traffic through the network, and how actually it's going to behave depending on the policies. Then this traffic generator helped me with that. And then Alejandro is going to show you the way that we can create it using manifest. But then it's going to show you another approach that is using Helm with templates, Go templates. And after that, it's going to show you something even better, that is using custom resource definitions. That is part of the Kubernetes resource model. Then through that, the idea is to help you to understand the basic of the solution. And then for the second part of this, I'm going to do the SDC, that is a schema-driven configuration that is an application part of the Kubernetes project. And it's going to show you some of the, I'm going to bring you a description of that. And then at the end, it's going to bring some analysis between the different technologies that you can have for network automation using, for example, this tool. Can we go? Okay. Then if you want to access the lab, you can just go and take this link directly. It's going to take you to our repository in GitHub. And you can just link on the code spaces, link on the README file, and you can start testing this right now. You don't need to, you can do it right now, or you can do it after, okay? And we're using GitHub code spaces. Can you, let's go to full, perfect. And then this is the repo, and then you can go to the README directly, link on code spaces, and I recommend you to choose the 4 cores option, because we're going to be running a couple of Kubernetes instances with Containerlab. And without further ado,
okay, cool.
Alejandro.
Thank you, Mauricio. Thank you for coming to this session. So as Mal mentioned, I will want to start talking a little bit about Kubernetes Resource Model. Also, explaining how it works in like we call that declarative way and so on. And I'm gonna run 3 labs that, as you saw, you can follow as we talk today, or you can do it by your own time later, or during your own time. And basically, the steps to create a lab are really self-explanatory, so it's easy to follow, and you can do that even in your own resources. For example, you have like a server or something, but you can take advantage of using GitHub code spaces to run the lab directly on GitHub, which is what we did for preparing this demo. So let's get started. So let's start with Kubernetes as a declarative solution. So the difference or the main idea behind a declarative solution is that in a declarative solution, you declare the desired state. For example, I want a certain number of servers running specific application running on different containers in a pod. So on Kubernetes, what we're gonna do, is gonna figure out how to make it happen. So it will make the management application easier to compare to manual scripting, for example. So you don't have to manually script every pod or every application you want to run. You just need to declare your state. It's like as you see a sample there, in a declarative approach, the user express his or her intent. So I'm hungry, I want noodles in the black cup. So the system will take care of everything. So, but in the imperative approach, you have to specify every single step that you want to be done in order to fulfill that intent or that requirement in this help. So in this case with Kubernetes, we are approaching everything as a declarative solution. Good. Next, okay. So let's talk a little bit about the KRM or Kubernetes Resource Model. So what is KRM? So KRM is how Kubernetes manages all its objects using APIs to define resources and their desired states. As we mentioned before, it follows a declarative approach, meaning that you specify what you want. Either you can do that through a YAML or a JSON file, and Kubernetes ensures that the actual state matches what the intent was or what the intent is. So Kubernetes also operates through controllers. So the controllers are the ones that continuously monitor and reconcile the resources in order to match the desired state. So it's done by the controllers follow like a CRUD or CRUD operation. So where we have create, read or reconciliation, update, and if you want to tear down your setup, also delete. So in summary, we can say that the Kubernetes Resource Model enables you to manage your application infrastructure in a declarative, consistent, and scalable way. So it will abstract a lot of complex underlying infrastructure management, allowing developers to focus on defining what they need rather than how it's implemented. Okay, so let's talk a little bit about Kubernetes API and resources. So APIs in Kubernetes define key resources such as pod, services, config map, etc. These resources, as I mentioned in the previous slide, they follow CRUD, so create, read, reconcile, update, and delete operations. So also Kubernetes has an extensive framework that can be extended, and that's something that we're going to do also during the demos, using custom resource definition. So if we want to introduce new resource type, we can do that through CRDs. So that's the way that you can customize your APIs in Kubernetes. Next. So let's talk a little bit about the difference between the stateless app and the stateful apps. And we're gonna be explaining a little bit more about this later. So in a stateless app, Kubernetes doesn't retain session data from the containers. So each request is independent, and if they need some kind of persistence, the persistence has to be handled externally. For example, if you have a database, it has to be external, that doesn't have to reside inside the pod. It's something that is not related to the deployment itself. This makes this kind of approach very scalable and easy to replicate. So because you don't need to have no local state. So if you need a persistent, you have to implement some external storage. And it's managed basically using deployments and replica sets, and using config maps and secrets to store the configuration. So a good example of the stateless app will be like a web server, could be a proxy, etc. So, in the other hand, so continue with stateless app. Kubernetes have this deployment workflow. So you have a YAML file, as I mentioned before, where you define your desired state, and then the deployments manage the application and the instance that you want to deploy for this specific configuration. So you have your config map for storing those configurations, and also the services that you have to define in order to ensure the communication between the application instances. And we will take a look about the services when we do the lab, because that's where we expose, for example, for the iPerf, the ports, TCP ports that we're going to use for the different flows, etc. And everything is controlled by a closed loop that ensures that the system maintains the desired state all the time. Okay. Next. Okay. So now let's move to stateful apps. So in this case, unlike the stateful apps need to maintain their own state and identity. So meaning that each replica isn't interchangeable. And I can put an example, like for example, a database. So you have database instance, and each one have a different, let's say, identity or different data store inside the different replicas. So it's not that you're going to destroy that instance and create another one, because it's not going to work, because you are going to lose all the data that you have in the other instance. So that means that for this kind of application, you need some kind of babysitting. So you need to you have some key challenges here. So managing individual state for each replica. So you have to babysit each replica. Be sure that you, when you tear down that replica, everything goes okay. All the data is being replicated to the other thing, to the other pod or the other container. Also, you have to ensure that the update happens in the right sequence. So that's another key point of stateful apps. And also, you have to enable or be sure that you handle communication between the instances. Right. Okay. So let's do a little bit of introduction on Kubernetes operators. So Kubernetes operators extend the Kubernetes API with a custom resource definition, or CRDs, as we're going to refer to them from now on. So this enable automation for complex stateful applications. So CRDs is a way that can ensure that the stateful applications are controlled in the proper way. So operators implement a control loop that continuously monitors the application state and takes corrective action if there's a deviation from the desired state. This approach also brings instance-based automation to Kubernetes, ensuring seamlessly orchestration for the application and their dependencies. So this actually is doing what I mentioned, the babysitting of this application for you. So making this application more resilient, more scalable, and easier to manage in production environments. Okay. Another topic that we're going to talk is about Kubernetes. It didn't change on here? No. Okay. Kubernetes API groups. So API groups help recognize or organize the resource efficiently. They follow a common structure. So in this case, you can see we have a structure where we have a group, we have a version, and we have a resource. And Kubernetes also support extensions for custom resource definition, enabling users to define and manage their own resource type, as I mentioned before. The flexibility allows Kubernetes to extend beyond its build capabilities while maintaining a consistent API structure. Okay. This is the last slide before the demos. So we're going to get into the cool stuff. So let's talk about a little bit about controller. So controllers basically work like automated supervisors. So basically what they do is that they ensure that the system always matches the desired state. They don't directly access the database, but use Kubernetes API to make adjustments. So now let's go with the cool part. Let's start with the first demo. So for this demo, what we're gonna do is do a simple use case of a traffic generator using iPerf, something that probably many of you already have done, like manually putting an iPerf server on one port of your lab or your network, and an iPerf client on the other side, and generate one traffic or multiple flows and test for some specific application. Sorry. So this is what we're gonna do here, but we're gonna have like some kind of a evolution in terms of how we're gonna accomplish this. So the first evolution or the first approach that we're gonna take is using a simple manifest. So we're gonna have a manifest in Kubernetes defining a server, defining a client, and that's it. It's very manual, so it's pretty straightforward. The second part of the evolution is going to use using Helm charts. This gives us a little bit of flexibility in terms of scaling, because we can reuse the same template to create multiple instances of that traffic generator. And basically, we rely on a values.yaml file when you store all the values of the different parameters that your traffic generator is going to take eventually, depending on how many instances or how many flows you want to create. Good. So this is the evolution that we're going to show during the demo. And as you can see, we are going to do like deploy an iPerf 3 instance. In this case, we can create multiple replicas for that instance, as you can see in the screen down below. And basically, the idea is to get multiple flows and stream. And Kubernetes, using kind, as will create the necessary resources in order to do multiple flows using iPerf. And this will be a really good use case if you want to do ECMP load balancing and test that your load balancing is basically working on your network. Okay. Here, probably most of you are already familiar with Containerlab. This is basically the lab infra setup. We have a Containerlab topology. As Mauricio already mentioned, we can spin up kind nodes using Containerlab natively. So we don't need to do that as by its own. So it's easy to deploy. And basically what we have here, this is a very simple use case. We have a SR Linux router in the middle with two interfaces doing layer 3 routing. And we have one Kubernetes cluster on one side and one another on the other ports. And basically we're going to inject traffic on those two ports. But the scenario in the middle could be as complex as you want. For the sake of the lab, we're doing something very simple. And from the Containerlab on SR Linux node that is we're going to spin, the configuration, as you can see, is very simple. Just a network instance or a BRF that is running two interfaces with two IP segments, 2/24. Okay, so let's get started with the video. When we record the video, it was running at like a 4x, so it could be a little bit faster than if you're following. So first, we're gonna build the iPerf images. This could be take a little bit longer what you're doing on your computers right now, but while I'm doing the slides, you can maybe complete the scenario. Okay, the next step will be load the necessary image, for example, the container images and the Kubernetes images. In this case, I also deploying or loading the SR Linux image as well. Next step will be load the kind image in order to deploy the kind nodes using Containerlab. As you can see, there are no deployments right now, but when I go and deploy my Containerlab topology, you see there's no context at the moment, but once I run my Containerlab topology, I will bring up those kind nodes. So after Containerlab is deployed, and don't worry if you see some warning messages. It's because sometimes it waits until the proper resources are created, so it keeps retrying. But at one point, all the nodes will be deployed. So once we get the summary from Containerlab, we will be good to go. There you go. So now we checked for the Kubernetes context, and we see that we have two contexts. We created two, one for the servers and one for the clients. Good. So this is just a lab setup. We haven't got into the 3 different scenarios that we're going to show. So, but this is going to be very common for everything. So the last part is apply the configuration to the Nokia SR Linux device. Some of you will ask, oh, you can do that directly on the Containerlab topology. Yes, but I wanted to show you how this how it's done manually here. Cool. Okay. So let's start with the first scenario. First scenario will be deploy with manifest, with simple Kubernetes manifest. So in overview, we're going to deploy the traffic generator based on IPERF 3 using raw Kubernetes manifest. We will just build a YAML file for the deployments. And we will have a definition also for the client, one for the service, and one for the services that will enable the communication or expose the TCP port that we're going to use for the different flows in this case. Okay. So when you're using manual deployment with manifest, there are some challenges. So first, the complexity of writing your own or managing your own YAML files, and you have to do everything explicitly on the YAML file. That will bring a lot of is error prone, so somebody can make a mistake when you're writing your YAML file, and also scalability. If you want to create like 100 flows or 300 flows, this doesn't scale. Here. So here's, as you can see here, here's the client manifest. This is where I define what kind. In this case, I'm creating a pod. So I give it a name. The container that I'm going to create using this manifest. The image that we already preloaded when we did the lab setup is right here. And also the port, in this case, we're going to use port 30,001 in order to create that single flow that is going to go to the server. Same thing, we're going to go to the service manifest, as you can see. And also, for the server, we also need to create a service manifest that is in the same file. It could be in the same file. And as you can see here, internally, the container will always use port 5201. But exposed to the network, we're going to use 30,001, which is the port that the client container will try to reach using the traffic generator. Okay, so let's go. This is the second demo. This is the first demo. The first was the lab deployment. So first, we deploy the server pods on one specific context, which is kind KA02, and then we apply the manifest specifically for the server. Good. And then we do the same for the client in this case. So we apply both manifests. And now we check if the pods are running. So we use a kubectl command, and we can check what is the status of our pods. So we have the server running, and we're going to do the same for the for the client. There you go. So now the next step will be if that actually the hyper traffic is flowing. So we can do that either going to the node and check on the interface, either using CLI or using streaming telemetry with GNMI, or you can just go to the logs as I did for the demo. You can go to the logs to the client container, and you can see that we have some traffic flowing there. So this is the first demo. So this is a simple case using manifest. Okay, the next one on the evolution of deploying Kubernetes will be doing Helm for automation. So in overview for Helm, we're going to deploy something that is called a Helm chart, which is going to use the same image, iperf3, but in this case, we had to define a chart with all the structure and files needed in order to rely on Helm for automation. So the advantage here is that we're going to use centralized configuration values in a values.yaml file. So instead of doing one manifest for each instance of the container that we want to run, we just create a template and then a value file, and on that value file is going to reside all the ports and flows that we're going to create in this case. Okay. So the benefits are obvious. So the management is centralized, and everything is being fed as a parameter from the values file. So it's more dynamic scaling. So you just need to adjust your values, and the needed replicas will be deployed automatically using the same template. So less errors. So what are the challenges? Still requires some explicit configuration for the ports, IP, and scaling, but it's only about the, what modification do you do on your values file. And there's could be some complexity with if you have too many parameters in the template, so it could be more complex. So you have to be aware of all the values that you need to inject to the template. Okay, this is the chart directory structure that you need in order to use Helm for automation. So you need first the chart YAML itself. Then you need the value file. This is where you define the image that you're going to use, the ports that you're going to use. In this case, for the client, what is the bandwidth that each client is going to use? What is the buffer size? What is the server IP, et cetera, et cetera, et cetera. So this is where you define your values. And then you have your template. So you have a template for the server, as you can see, with your specifications. You have another template for the client. This is where you feed with all the parameters. What is the server IP? What is the bandwidth? What is the buffer size, et cetera, et cetera, et cetera. And then you have a service definition, which is what we use in the manifest. So you remember that we use the service manifest to expose the ports that then the client is going to use to communicate to the server. So let's go to the demo. Okay. So the first step will be install the Helm tool. So that's pretty easy. Just you go to the right directory, not the beta mistake that I made on the first one. And then you create the chart package. Then you install the Hyper servers instances. And obviously check the status of the pod to check if everything is running. So as you can see, we created 20 instances of the server. And as well, we're going to create same kind of a number of instances for the clients. I will check the status of the client. There you go. We have 20 clients as well. Now the next step will be check the activities or check the logs to see if the traffic is flowing. As I mentioned, we can do that either on the instance itself, or we can do it directly on the switch, checking the interfaces. Just a heads up, when you run this in your lab, obviously you have to use the name that was auto-created for your particular instances. And there you go. There are multiple flows running from that client towards the server. Okay. We can do that also if we SSH to the switch and check the traffic on the interface. Yeah, I know, I'm using CLI commands. We should be using GNMI more. I just did a watch command just to check the increment as we go. And you can do it directly with a show command, or you can do it also inside the node using a YAML model. So you can retrieve the YAML path specifically for the interface contours, as I'm doing right now. There you go. So checking basically this, using YAML model, the statistic of that particular port. By the way, at the previous demo, I didn't mention the last part is that at the end you had to clean up this setup. So you had to destroy this particular scenario in order to move forward with the next one. Cool. Great. Okay, the next example and the last of this first part, there's also another demo coming from Mauricio, is using CRD and controller for have a more declarative automation. So in overview, we're gonna introduce a custom resource definition or CRD for IPERF3. So for this traffic generation in this case. We're gonna use a custom controller reconciler to manage the instance declaratively. So we will tell I want this number of flows running on IPERF, and the system will take care of everything. So the process will be create a traffic generator CRD with field like replica, buffer size, and bandwidth that you can manage, and then create a controller that will basically reconcile and check on if the desired state is what's happening on the network. So this is an example of the CRD, as you can see here. You have this as well, and this is where I say, okay, this is my intent. I want to run this CRD that is called traffic generator, and I want to run 40 replicas, and each with 40K of bandwidth and 4K of buffer size. So this is my intent. This is what I want. Okay. So the benefits is that we're finally using a declarative and simple way. So just define the desired state in the CRD, and that's all. And the controller will handle the scaling, the updates, and the resource reconciliation if something goes off. So this will reduce error because basically the only thing that you have to modify is your CRD in order to have different scaling or scenarios using the same CRD. Okay, let's go to the demo. Okay, go. So first, as you saw on one of the slides, we created traffic generator CRD. So for the server and also for the client. Then we check the IPERF server CRD setup. So then we need to apply Python codes for the reconciler. So basically, Python codes is the one that's going to check that we are meeting the criteria or the desired state. Then we also obviously check if the controllers are running for both the servers and the clients. So we have the server controller up. It takes a while, as you can see. It took me like a couple of seconds to do it. And now I'm checking the client, and the client is up and running as well. So now I check the CRD setup file. As you can see, we have this is for the server, and also we need to check the controllers if the controllers are properly running. So now I can check in the pod how many instances are running in this case, and I can see I have 10 servers running. But if I go to the clients, there were only 5 running. It's because when we created the iPerf client definition, we only give a range of 5 TCP ports, and that wasn't enough. But once I go to the file and fix that error and reapply the client configuration, now you will see that we have all the ports, and successfully the traffic is flowing. That's pretty cool. Yeah. Let me go to. Well, then you have to clean up. Don't forget to clean up after the lab. You don't want to mess your other setups. Oops. I think I did one extra. So in summary, let's take a look at the evolution that we just did. We started with manual manifest. So what are the pros? The pros is we have direct control over the configuration. The cons is that it's time consuming, it's prone to errors, and it's not scalable. If we go with Helm chart, it gives us a little bit of scalability because we can reuse a template in order, and also just focus on the value file, and they give us a little bit more scalability. Yeah, the cons is that you cannot use too many parameters because it will increase the complexity of how to deal with the template. With CRD, the pros, well, full automation is 100% declarative, simple, the dynamic scaling, real-time status, and reporting. So, but there's a con. So how we created the CRD, how we deploy that. So it will take like more development efforts and skills, which maybe could be a little bit overwhelming, especially for a guy like me who comes from the networking side and not a native developer. But they're good news. So they're open source tools that we can leverage on in order to work with CRDs. And actually, Mauricio is going to talk about that later. So this was just the starting point. As we mentioned, you can apply this same scenario or scenarios to a more complex topology. Actually, we have another demo here where we have a complex MPLS network running LSPs. And basically, we want to do the same. From point A of the network to point B of the network, we want to inject multiple flows. And you can create your topology in Containerlab, as you can see right here. But this is basically at the end what we're going to test. So we have our Kubernetes cluster creating a bunch of iPerf clients on one side, and a Kubernetes cluster on the other side creating a bunch of iPerf servers, running a VPRM with 2 interfaces. It's the same case. The only difference is that in this case, the 2 interfaces are in different routers, and in the example that I did before was the same router. So we will have a PCE controller that basically is going to enable or disable the different LSP that are going to go through the network. And this is in order to check if the ECMP load balancing is working properly. So we'll have multiple clones of the LSP, and then we will check if those LSP will get properly load balanced through the network. So for this particular demo, we obviously will leverage on Containerlab using Nokia nodes for the deployment, and we use NSP as a PCE. Mauricio is going to talk a little bit more in details about it, and we use Grafana to display the information of the traffic that is running on those LSPs. So let's get started. So as you can see, we're using a BRSROS image from Nokia, and you can see the multiple client and server instances running iPers that are running in the network right now. So what I'm gonna do right now is we're gonna deploy different LSPs. In this case, we'll have only 2 running at the first time. We're gonna spin up 2 more. As you can see now, we have LSP A1, A2, A3, and A4. As you can see the graph on Grafana, you can see now that the traffic is being load balanced among the 4 LSPs using the iPers traffic generator that I just created. If I go back to my NSP platform and disable 2 of the LSPs, the traffic will get back to be distributed on the 2 remaining LSP, which is LSP A1 and LSP A2. So you can see right now, so the traffic now is going only to 2 LSPs. It's a pretty cool way that you can test your lab environments and setups. So that's it for me. So I'm gonna hand the stage to Mauricio. So he's gonna talk a little bit about Kubernetes Resource Model for network automation. Mauricio?
Thank you. Okay, then the most important thing of this exercise, of this evolution on how we were using this application in Kubernetes, is to understand you can work with something very basic like the manifest, or you can start taking full advantage of Kubernetes and create things like the CRDs and the reconcilers. Then the CRDs give me the option to extend the APIs, the standard APIs that I have in Kubernetes. Extending those APIs, I can take advantage of most of the ecosystem that you have around Kubernetes, like if, for example, use Argo CD and connect my source of truth or source of intent directly from GitHub to this solution. And the reconciler probably is going to be a little more challenging because you need to do some coding to watch events on those CRDs, any change that can happen on those CRDs, and then apply those changes to your applications. Also, it was important to show you the CRDs came because of the concept of stateful applications. And when we thought about stateful applications that they need a lot of babysitting, it's the same concept for routers, for the network. They require babysitting. This is why we are taking full advantage of the CRDs and the reconcilers. Okay? Then the 2 keywords here are CRDs and reconcilers. Then if we want to see what are the differences between using Kubernetes as a container orchestration solution or using Kubernetes as a network automation approach is, well, the primary use case is if you are working as a container orchestration, you're going to be probably leading with applications like Nginx and web servers and databases. If you go to directly to just use it as a network automation tool, it's gonna only be used to manage my external infra, and I'm not trying to use any of the network machinery that I have inside Kubernetes. You're using the concept of CRDs and reconcilers now to start automating things directly on the network infra. What other things are important, for example, for container orchestration, service discovery, load balancing, but it's not relevant in the case of network automation. They're both declarative, but in the case of container orchestration, is declarative for the manipulation of any application inside the cluster. In the case of network automation, we are using this to create declarative or your desired state of your infra, your external infra of routers or switches. And then the other important thing is if the solution is event-driven. Well, in our case, in network automation, everything is event-driven. This is why CRDs and reconcilers are so important. In the case of container orchestration, yeah, you can have some applications that require some deployments and rollouts, but not everything is going to be event-driven. But event-driven is key in the case of network automation. And also is the concept of how much of this Kubernetes resource model I'm using for network automation. Well, it's heavily used. It's so heavily used that actually we need to add the APIs in an independent server. We are not using Kubernetes standard services in order to make it work. We put the APIs and we store the APIs and we add the controllers. We put everything in an external, in another application. Then, if I want to see this more visually, when you are dealing with container orchestration, you're going to see a massive cluster of many nodes managing multiple services. But in the case of network automation, you can start with one instance or the 3 controllers if you want to bring some high availability to that. But it's not going to be heavily in the amount of pods and workloads inside the Kubernetes, because we're trying to use the Kubernetes resource model to just apply changes on my external devices. Now, there is something that we are not covering in this tutorial, that is Choreo. That is another application in Kubernetes. But the difference, for example, between using SDC or the KRM with inside a Kubernetes cluster is we are now working. There is a project that is trying to go in an approach to make this very lightweight, and then we are taking the Kubernetes machinery, the KRM, and putting that in a lightweight application, and we are removing the Kubernetes cluster. And now you don't need to worry about the Kubernetes cluster. We are also adding this, trying to make it a little more friendly. Instead to go and start coding with Go, if that is a natural programming language for Kubernetes, you can use a Jinja template, you can use Python, and it's gonna start working from the day one with JIT. Then you can start having version control directly on any change that you're gonna do on your network. Then those are very important difference between SDC, that is fully based on the Kubernetes resource model, but it's using the Kubernetes cluster, and Choreo, that is that's still a work in progress project, but we are very excited to see how actually it's going to end. Today I'm going to talk about SDC, about a schema-driven configuration, and why we think it's important. You saw it by yourself when we were working with the traffic generator. You needed to create CRDs from the scratch, and you needed to create also the reconcilers, create the controllers. Okay, let's say now I want to have a CRD as a representation of the full configuration of my router or my device. It's going to be very challenging. And then the idea is SDC is giving you the opportunity to take directly from the JIT repository any of the YAML schema files and create the CRDs without the hassle to try to design that for on your own. Then the solution is multi-vendor, because now we have even companies using that today, and they are working with Arista, Juniper, with Nokia. We have even one with Ericsson because they're trying to use it for 5G. Then you see they're taking full advantage of all the new models right now. They have everything defined through YAML, and then using this solution, you can just go create the CRDs, just defining the location of where are my YAML schema files, and then submitting that information directly to the schema server in this solution. this is another thing that is very important. As soon as you do that, you don't even need to worry about the reconcilers, because the reconcilers they're gonna identify that information, and they're gonna start validating anything that you're gonna put as a desired state of any of the configuration of your devices. Then you don't even to be worried about coding or developing your own reconcilers. Everything is also coming as part of the solution. And the other important thing that is coming with this solution is when you are creating your Django schema, it's also taking the mass statements and the conditions. And then you can actually, before to go and do anything on the device, the system is going to validate that this is going along with those rules, and then it's going to do the changes. This is why the idea is to introduce these two projects. We're going to only talk about SDC, schema driven configuration, but I'm going to talk a little also about Choreo later to show a comparison between SDC and Choreo. Then, like I told, SDC is giving you the opportunity to start taking any of the Django schema files of any of your routers and switches, put it on the schema server, and start automating all the settings, all the management of your configuration directly from there. All the reconcilers are actually working. Is ready to go and work with GNMI and netconf. It's already on the software, and also it's going to help you also to resolve any conflict or any deviation that you can have on your network, because it's very intensive in getting information of the state of your network and comparing this information with your desired state. Okay. Well, Choreo that is not being covered is trying to go a little further, and it's gonna also give you some higher level of abstraction where you can define topologies, nodes. It doesn't matter what is the vendor, and you're gonna leave the lower levels of the solution to just take care of the settings that you need. Doesn't matter what is the vendor that you're going to be using, you're going to let the system to figure out that. Then Choreo is actually going a little further. Then let's go with the schema-driven configuration. Schema-driven configuration is an open source project that is part of KubeNet. It's declarative because it's using the Kubernetes machinery as part of the solution. You can just go and define your upload all your Django or submit all your Django files directly from a Git repository, and for any of the model or brands that you have. There are some rules. Probably you need to try to make the Django consistent, but in the documentation we already have some models of Juniper, Arista, and Nokia that you can use already. I think we have something with Sonic too. And then is GNMI and netconf. And also it's going to help you to solve any conflict management. You can define priorities of any of your configurations on the desired state, and also it's going to solve any deviation that you can have on your network. It's going to continuously check what is the state of your running configuration versus your desired state of the configuration, and it's going to change that back if someone try to just go and manually change something. It's multi-vendor because you can actually basically you can go and submit any of Django from any vendor and model. And the other good thing is, from the application you can check not just the desired state, you can check even what is your running configuration, what is the actual state of my network. I don't need to go to the network to check that. And it's going to show you, well, as soon as you create a snippet for any configuration, it's going to show you, well, this is the part of the configuration that is being managed through the tool, and this is the part of the configuration that is then managed. Then you can compare even that sort of information directly through the tool. The tool have some components. You have the schema server where all the Django schema information is stored. I think it's better if I go to this diagram. Then you have the schema server where you are storing all the junk information of your devices. And then you have the config server. The config server is the one that is storing all the information for the CRDs, all the extended APIs that I'm giving to Kubernetes. Kubernetes, in this case, the controller, the API controller is just acting as a proxy. Then every time that I go there and I try to define the desired state through declarative YAML file, it's gonna go directly to the controller, and it's gonna the controller is gonna act as a proxy directly to the config server, where all my information of the APIs are actually stored. It's also, you have all the reconcilers are also in the config server. You can see that between all the elements we are using gRPC to interconnect the different elements in the tool. Is optionally, because we're using Kubernetes APIs, you can add Argo CD or Flux, and you can connect this with a Git repository, and you can have your source of truth or source of intent directly in Git and have version control. We have the data server that is the actual element that is going to the devices. Could be virtual, could be a cloud native device, and through GNMI and netconf applying the my desired state, and also is using GNMI or netconf to extract information of my running configuration or my current state of my network. The data server also is validating the information of my desired state with the running state and calculate the differences. And then when I'm pushing information to the network, I'm not pushing everything. Okay, it's just going with the differences of regarding my running state. And also the data server is using all the mass statements and conditions that I have in Yang to validate my desired state before to go to the devices. And you have the cache that is keeping the information of my running config and my desired state also in some place apart to make it to bring better performance. What are the options that I have with this tool? And by the way, this tool is also available in code spaces. If you're using code spaces, I don't know if you try to use it, it's going to take like 10 minutes to start up, okay? And if you leave it idle for 10 or 20 minutes, maybe it's going to shut down. Then be careful with that, okay? What we want to show in this demo is basically how can I do a basic config using this tool in a device in Containerlab. You also in the lab, I'm not going to show this in slides, but in the lab you're going to also have the option to do a config set. A config set is because everything is, we are taking full advantage of the Kubernetes machinery. Also, we are taking full advantage of the labels. And then every time that you are creating a device or target, you can define labels about the location or the role in that are having in the network. Could be a PE or could be, for example, a spine. You can add many labels as you want, and based on those labels, you can go and create settings for many elements at once using this config set. You also had, like I told before, a way to see the running config, and you can just go and take a full copy of the full configuration of your switch. You can use this for backup, restore, or to create new configuration snippets. Okay, and you also you're gonna have the option to see the manage configuration from the tool. Then what I'm not managing from my tool right now. And Yang is coming with different mass statements and conditions, like a pattern in this case. Then the tool is going to help me to take care of if I'm not making mistakes, for example, with the syntax of the name of a interface and things like that. Everything that is coming in Yang of that kind is going to be validated as part of the process before to go and apply my desired state of the configuration. Then if I'm gonna upload my YANG, the only thing that I need to do is I need to provide information of the repository. Maybe it could be a branch, or it could be based on tag, and define show what are the models that are going to be actually submitting in the schema server. I can also put the deviations. I can exclude some information that maybe is not relevant for the router. And as soon as I do that, I can also go and start adding a connection profile. But for example, I can say, I prefer these routers to be connected through GNMI, or I prefer to push the configuration using netconf, but read the running configuration using GNMI. You can actually define these two different things in two different profiles. You have the secret, where you can add the credentials. Secret is a very known solution, a very known asset in Kubernetes. If you need to store sensitive information, you can put a lot of control on for anyone to access that information. And you create the discovery rules. And you see in the case of the discovery rules, you can add an IP of the target, or I can add a segment, saying go to that segment and create all the devices target based on that segment. Then in this exercise, I'm going to show you how we can start submitting the YANG schema that I just showed on the slide. And now that this is actually created, I can check if actually this is working. And the solution is going to give me all the information that I need directly from the CRD. And then now I can see, for example, okay, it's ready. This is the provider. This is the version of the model that I'm using, and this is where it's located. And I can see this directly from the tool. As soon you see that it's ready, you can start now creating the discovery rules and the profiles and the secret. And what I'm going to do right now is I'm going to start adding that information I just created. It's the same information that I showed on the previous slide. And then as soon as created, the system is going to go and discover the devices, and it's going to bring me information of those devices. Come on. I did it accelerated like you did. Yeah. Then, and now you can see the devices. You can see the devices are actually online, and I can start using them to start managing the configuration of that from this tool. And as soon as, well, it was too fast, but I got the full configuration of one of them directly. Okay, this is the real time. Huh? I know I didn't accelerate the video. And then now you can see for example, I want to see what is the status of a part of my configuration. In this case, I'm using the path, and I'm trying to see what network instances are present right now in my router. Okay, I only have management right now. But as you can see, as soon as you start creating the YANG schema for your model, for your vendor, you just need to go and create the discovery rules, the profiles, and now you can start manipulating your device. Then now let's apply. We can start applying configurations, specific configurations or configuration snippets directly to that device that we just, a bunch of devices we just created. And as soon as you apply, well, in this case, I'm gonna create an interface called System 0. It's a dummy interface, but I'm gonna try to use this exercise to show you how I can resolve deviations with my network. When you create a configuration snippet in the tool, you need to put a name, because it's going to help you later to follow up what is happening with this new configuration. You can define priorities on that. and then you can resolve conflict between overlapping configurations. And you can add the labels. And then as soon as you apply that new configuration, you're gonna see the system is gonna show you if actually it was successful or failed, because maybe it's not meeting one of the conditions. Then I'm gonna, on the next exercise, I'm gonna show you, I'm gonna try to make this fail 2 times. First, I'm gonna try to create a value that is not going along with I had defined in Django. In this case, is admin state. Admin state can be enabled or disabled. I don't have more options than this. I'm gonna try to use shutdown and see what is gonna happen. Okay, and also I'm gonna try to make changes in the interface when the interface is disabled. That is also you can do that. Okay, then let me go now with the video. This is in real time. I should have started before. I'm checking right now if the system 0 interface exists in the router. You can see that there is nothing. And then and now I'm gonna start. I'm gonna see my file. You see that now if I'm creating my configuration, I'm putting a name because it's gonna make it easy later to identify that. And I put in shutdown as my value for admin state, and should fail because this is actually not part of the conditions that I have in my Django schema. Then I created the configuration. I'm gonna check the status of that, and it's gonna show me that it is actually has failed. Then I want to see why actually fail. The system is going to actually the Django, and it's gonna show me the reason based on the Django conditions to understand the reason that why this is failing. And this is not failing on the device, it's failing in the tool. It's not doing anything with the device until it's not fully validated. Okay? Then you see now from the Django schema, it's showing me the information. Okay, you can use shutdown, you can use disable or enable. You don't have any other option. Okay? Then I'm gonna try now to go with another condition that is trying to make changes in an interface that is disabled, and it's also is giving me another error. It's telling me no, you can't do that if actually the interface is disabled. Then now I'm going to apply the setting that actually is going to work, the one that is using enable and is creating everything by the book. And if I go and check my configuration, now you see it's ready and it's working. It was successful. And the amazing thing is that we are trying to show here, you just need to submit your Django schema. And doing that, all those rules are implicit in the tool, and they're being used before to go and submit anything to the devices. Then now you can see the information is in the device, and we are going to try to do, we are going to change the description of that dummy interface. And doing that, we want to show you how any deviation on the device can be resolved directly through the tool, because the tool is getting the running state of my configuration continuously. Then if you see, I just change the description of my dummy interface, and I'm gonna go to the device, and I'm gonna do use the command watch to see how long it's gonna take the system to go and change it back. Okay. Hopefully it's not gonna be too long because but the system, like I was telling, is continuously getting the running state of my device, is comparing that information continuously with the side state, and it's doing the calculations to only do the changes that are required. It's not going and try to put the full configuration again. Then it's very optimal from the point of view of changes that you can do on the device. And okay, now change. Then the system Just identify the deviation and solve it. Okay. You can do a config set like I told you. You can use, for example, I can use the label of the region where all the devices are located, or the role of the device. I can create as many labels I want, and that can help me to push configurations to many devices at once. And if you do that, it's gonna add as a suffix the name of the device to help me out later on following this app is actually work or not, or if there was a reason that why it's failing. Other important thing is, well, if you are familiar with GNMIC and you feel that maybe it's going to be a struggle to start creating all those configuration snippets, you can use GNMIC with the Yang schema and extract information directly from the device, and you can just go and modify the values on the components of that YAML file to have the snippet that you want. Okay. Then what are the benefits of SDC? First is declarative. You could see that I can just go and touch any configuration of the device. As soon as I have the junk submitted in my tool, I'm ready to go. It doesn't matter the vendor or the model. And this is why we say it's multi-vendor. Scalability, because it's in Kubernetes, it's very elastic. I can work with almost any size of a network because we are taking full advantage of the scalability of Kubernetes for that. And again, I'm not running pods. The only pods that I have, or the only applications that I have in the Kubernetes cluster are related to the tool. I don't have anything else. Okay. Conflict resolution, you can put a priority for any configuration snippet to resolve any overlapping issue. And also it's going to help you to solve any of the deviations with your devices. I tried to do analysis on my own for this tool. Maybe it's too soon to do that. But I just wanted to try to show you what could be a difference between something like Ansible. Okay. And I like Ansible. I use it a lot. But my only, well, let's go with advantages first, and then I can go for other things. Well, there are many advantages of Ansible. First, it's very easy to set up. And every time that you need information to create anything, it's always online. You always are going to get information from somewhere. There are many communities around that also. There is a large ecosystem around that. And then it's very lightweight that you can even run this in a virtual server or even in a container. Okay. SDC is, what I like from SDC is it's very granular. I like this. It's very, very intelligent in the way that I can calculate the changes between my running config and my desired state, and it can just go and do the changes only with the calculated values. I don't need to go and push the full configuration again every time, and that could be sometimes overwhelming for the network. It's going to help me with the deviations of anything that I can have in my network. And I like also, because it's working in Kubernetes, can scale very effective. Okay. Choreo, Choreo is the part 3 of our lab. If you want to try it, it's in the lab. It's the part 3 of the lab. But Choreo is going a little further. They're taking the Kubernetes machinery, putting that in a lightweight application, removing the cluster, then no more Kubernetes cluster. But we are taking full advantage of the KRM machinery. And then you have all the concept of the APIs, the CRDs directly, but in a lightweight application. It's natively working with JIT. Then you can do, for example, a pull request of your new configuration and get like a sort of workflow with approvals. And it's also it's trying to be very friendly with the people that doesn't have too much coding experience. Then it's trying to help you bring in some abstraction of any business logic that you want to create through Python and also using Jinja templates. Okay. What are the challenges? Well, I don't like the hand going down, but okay, let's say the challenges is Ansible. What I don't actually like is imperative. You need to go every step on the way. You need to define everything that you're going to do on the devices. Sometimes it could be very overwhelming. In the amount of code. I have playbooks of almost 2,000 lines. And sometimes it's very hard for me even to keep it up. And every time that I'm creating something with Ansible, like a playbook to create things, I need to create the playbook to also to destroy it. Because when it's stuck in the middle, I need to go run something to go and remove everything that I did. And then it's very overwhelming also for the devices. When I'm using Containerlab, you can see actually it's taking some time. And it's very basic to resolve anything regarding errors and the reporting. This is my feeling, by the way. Okay. SDCIO, I feel the big challenge is you need to know Kubernetes. And I think that could be a little challenging for many of the network professionals. Could be resource intensive because of the Kubernetes cluster, and also have a lot of reading operations to always keep the running state updated. And there is some complexity if you want to keep the version control, but there are tools that you can have like Argo CD in order to use your Git repository and connect that with APIs and start getting also version control of what you're doing with your sort of intent or sort of truth. Choreo, I like Choreo because it's very lightweight and very easy to use. Choreo is trying to bring some sort of Ansible experience, or no Ansible experience, Terraform experience to the user in the way to use it. And then it's still emerging, it's still work in progress, but it's growing. And you can go to the KubeNet YouTube channel and you can see some presentations about that more in detail. I also require a little about the Kubernetes, at least how you can work with the reconcilers and how you can start working with to create your own business logic and so on. There's some, maybe not like SDCIO or to work your KRM from scratch, but there is some complexity also related to that. When I think about OpEx, CapEx, well, Ansible is very low because you can just go and download it and put it in a container. And doesn't require so much skills because most of the information is actually online. You can use even ChatGPT to ask for anything you want. SDCIO have a little higher OpEx, and because you need a person with a little more skills working, for example, with Kubernetes. There are more people with experience in Ansible than in Kubernetes, probably. And again, those are my thoughts, okay? Maybe I can be wrong. CapEx, well, you need to create your cluster. But the cluster, in this case, you see that you can create a kind container instance and you don't need too many resources. But you need to create a cluster. You need to have the cluster. But if you want to do it, for example, in a bigger scale, you're going to have to go serious with the Kubernetes cluster. But it's better for long-term or large-scale ecosystems or networks, because it can scale very fast, and you see that it's very optimal. It's not overwhelming the systems, because it's usually when it's trying to push the configuration, it's going only with the differences, and it's very easy to follow up and easy to set up. If you have the junk schema, then there is not so much things that I need to do with this, because it's already designed to work with the network, to make it easy for the network professional to just upload the Janux schema and start playing around with it. Choreo is very low because it's a lightweight application and you are removing the cluster. You don't have the Kubernetes cluster for that. Also, the CapEx is low because the skills or the infra that you need for that is very when you are removing the cluster equation from the tool, is lowering all the the required skills and also the compute requirements. And from my point of view, it's also very cost effective if you want to adopt a modern network automation tool with the same experience that you can have with Kubernetes today, and also with Terraform. It's something also very dedicated to network automation versus other tools that are more wide in the purpose, like Ansible. From use cases, what I think is, well, I think Ansible is pretty good for appraise fingers on the devices, or to do like some sort of minimum maintenance. And I think somebody felt identified with that comment. But if you want to go more seriously on the settings of your network, I think SDCIO could be the best answer for that, because it's very scalable. If you had a big network and you're thinking long term, I think you should try to invest time in that. Something that I think I didn't mention is we have companies today using SDCIO. We had a company actually is very serious on that. That is Swisscom, and they are working with that for 5G, using, I think it's Arista and Ericsson, if I remember. Okay, I got the note over there, then I wasn't wrong. And then you have also, from my point of view, SDCIO can help you with all the deviations, and if you want to go seriously to work with modern network automation with a big scale, you should consider a tool like this. Choreo is still a work in progress, but it also can help you to start understanding the KRM model. Is a little more simplified than trying to work with Go and create your reconcilers. You can create your own abstraction of the network, and the good thing is you don't need to depend on the vendor. Then the abstraction at the top could be vendor independent, and you can let the system to resolve any problem later at the lower level. You can even connect Choreo with the SDCIO using the Junk schema if you want, or you can create your own configurations with Jinja templates. And it's also working from the day one with JIT. Then you can have a really great version control from the day one using also Choreo. Almost done. Then I'm going to invite Alejo to help me with the, the last slides. We'll try to put some final words on this tutorial.
Okay, I think I'm good now. So for final words, first of all, thank you all for attending this session. And personally, from my side, I know that could be a little bit overwhelming, especially for those who come from the network engineering side, and we are not native developers at SMAU. But we have some tools and we have some kind of evolution path that we can take in order to adopt Kubernetes as a network automation tool. So you can start as simple as using simple manifest. Then you can evolve to have some kind of like a leverage on Helm charts. And then why not move to building your CRD? So you can take your own pace. You can do it at your taking baby steps. And we have there are plenty of resources online. You can also send us an email or something, and we'll be happy to help you.
Thanks. And then my final word is, many people is talking about AI today. There's so many presentations about AI. But everybody's skipping the thought of, if I don't have a machine-to-machine in my automation, I cannot even start thinking about AI. Because AI needs to work on something that is going to be very, very human remove. You need to remove the human factor from that. Because AI can give you some, well, you have the hallucinations of that problems, but you need something that helps your AI to take real control of the settings on your network. And you don't have the concept of machine-to-machine from the point of view of network automation. It's going to be almost impossible. This SDCIO could be a really great step on doing that, because it's going to help you to create the declarativeness of your network automation. It's very modern. It's not going to overwhelm your switches. It's very scalable. You see, actually, it's very easy to just go and submit any of your junk schemas and then start playing with this right away. Then that could be a really nice first step going for AI, autonomous networks, or whatever you want to do with AI. We have the part 3 of the lab too. If you want to check on Choreo, that is, we didn't include it on the here directly on the tutorial because of the time, or otherwise we would be talking here for 4 hours, and we didn't want to do that. But I invite you to go and check also the part 3 of the lab. And there are some additional resources. There are many information about Containerlab in the Nano YouTube channel. You can see also information on KubeNet YouTube channel about all the tools. If you want to go more in detail about that, like a schema-driven configuration or Choreo. And you can also visit the Nokia developer portal if you want to understand. We show a video of using NSP, creating LSPs and removing LSPs. And well, if you want to know more about it, also you can go to the developer portal. And basically, we're ready for questions.
Thank you. Any questions?
It's good or bad? The time is good. More or less. It was for me to prepare, but I me feel more confident.
You can tell us why you were laughing in one of the slides.
I figured that out.
No, 80% of our network touches are Ansible. It's like, oh man.
All right.
But yeah, I can see the advantage.
Yeah, it is.
Set up a little overwhelming, but
Could be, yeah.
Well, we are going to have a comment here.
Nokia.
It's not.
It's not what I thought.
It's okay.
Yeah, now it's okay.
So the other thing, I think it's fairly new, right? What the other thing that we added to the tool, so I think Alejo and Mauricio, and Mao, they talked mainly about the config side. We also recently added state. So in other words, you can basically say, I want to retrieve, let's say, streaming telemetry from the device. And so we stream it through Prometheus as well. So in other words, there is a CR there. I mean, if you look to the documentation of SDCIO, you will see that there is a way to, you can basically ask for certain state information and we start to stream it. And at the moment we export by default to Prometheus. So you can have your graphics and stuff like that. So that's an addition that we added a couple of weeks ago. So in order to basically have both, because what you typically see in automation is you, on one hand, you want to push configuration to the system. The second thing is you also want to retrieve, let's say, yeah, so it's Prometheus and then you put a Grafana dashboard with it. Correct, yeah. It's all open source, so we try to...
You're using Prometheus, sorry?
Yeah, so by default right now we export to Prometheus, right? So that's the default thing. The plan is to add more exporters. So some people like to do like Kafka or NUTS or ISO and other, or like InfluxDB or something like that. So at the moment, choose Prometheus because it's the most widely deployed.
The most popular right now.
Yeah, but yeah, the idea is to add other capabilities.
You are showing the Prometheus exporter for any Prometheus to start grabbing that information and then you can put it.
So one of the things that we do is because we have access to the devices, right? So we augment. What you typically get from the device is the raw data, right? Now the problem that you have in the databases is you want to get context, which software version, which schema, which device. So we augment some of the data into Prometheus with dimensions. They are being added to actually give context, a little bit more context on the device.
You are also giving information about the tool, how the tool is performing?
Yes, yeah, correct. So that's the second thing that we added, right? Because on one end, this thing is doing a lot of stuff, right? So if you want to actually deploy it in production, you also want to get, so there is two usage of Prometheus type of thing. One is the devices it manages to get state of it. The second thing is, how is the tool performing? Like, so how many processes do you use, how much memory is it using, how much CPU, so it's getting statistics. So, and we use open telemetry, and then we also export it to Prometheus to get information about the health of the system itself, right? Because at the end, if you use this thing is going to be an important element in the infrastructure, right? So you want to actually, I also get information about the tool itself. Is it performing well? Are there memory leaks and stuff like that? So to get information about that. So there is two usages of Prometheus. One is basically the internal health of the tool itself. The second thing is actually getting information from the devices it manages and exporting that information. Correct. So, okay, so that's a good question. So today, if you look to SDC,
Could you repeat the question for?
yeah, so the question is basically, how does the tool know about the vendor specifics related to the data? Okay, so the tool itself is so it's a vendor agnostic tool, and so the reason we call it schema driven is because the schema defines how the vendor, let's say, acts, right? Yeah. Correct. Correct. Yeah. Yeah. Indeed. So normalization. I call it normalization. Yeah. So we don't do that in this tool. So this tool is basically giving raw data from the vendor to the system. One of the things, so Choreo, right, as a tool is doing the abstraction. So in other words, and we don't have that for state yet. We have that for config, right? So in other words, for config, what happens, if you look to Choreo, what you do is you get what I call an abstract vendor device, vendor agnostic device configuration. And then there is a plugin in Choreo, for example, using Jinja templates that invokes the specific vendor and the version that is behind that abstracted model, and we convert. Yeah. For the state, we don't do that yet, but we plan to add that, right? So at the moment, it's just correct. So, but we have to, first of all, so we go step by step, right? So at the moment, we are not yet, for the state, have that normalized data format. But the way it would work, or it's going to work, is basically we get the raw data from the vendor because you have to get it from the device. And then we have let's say, also a normalization function that converts the vendor specifics of that specific data into a normalized data model that is then generic for, and that is vendor agnostic. But we are not there yet. Correct. Yeah. Correct. Yeah. Yeah. Correct. Yeah. 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 That's yeah. 100%, yeah. And so we are not there yet, okay? So, but we plan to do something like a plugin so that you have an exporter. So you basically get the data, we know the vendor, and then through a plugin, we can actually convert it to the normalized model. But that's work to be done. Yeah.
Well,
I understand. If people want to help, this is all open source, by the way. 100%, yeah.
Yeah. Well, this is why we say the Choreo is a still work in progress. It's an open source project, and you are also invited to collaborate with that. And Choreo is going to give you the top layers abstractions, vendor independent, and then you're going to let the lower levels to resolve what the vendor is going to require for it.
If you look under the hood, it's a massive undertaking, right? Because that's so the other I think interesting part is that this also works. So this actually works for optical.
Well, this is something that actually any device, gRPC or network device, can be actually put on the SDC, even the optical devices, and now they're starting to use the gRPC and netcode.
So at the moment SDC is Yang. So at the moment we have a Yang dependency. So any device that does Yang, doesn't matter what it is, you can actually get
Yeah, that also is pretty good. But again, like I was saying, the step to go machine to machine is still, with tools like this, could be a reality. But we need more people adopting something like that. Okay, we're good.
I think we're good.
We're good.
Thank you very
Well,
much.
thank you very much.
Yeah, thank you, guys. And thanks, Wayne, for the comments and the insight information.
We got here for the tough questions.
Thank you.